Okay, so we're talking about section 2.6. We're going to add and subtract fractions and mixed numbers with uncommon denominators. And so this is a little bit different because uncommon is meaning not like, denominators that are not the same. Once we get them to be the same, then we're going to follow the exact same rules for adding and subtracting just like we found in 2.5. So the only new part is going to be finding the common denominators, and then you follow the rules from 2.5. All right, so let's get started here. Our first problem is going to be 3/4 plus 1/6. I know what you're thinking. Let's just add the top numbers and add the bottom numbers, and that's not how this works. Remember, adding and subtracting, you have to find a common denominator, bring the denominator over, and then add or subtract the top numbers. And so that's still the rules, but we have to find that common denominator right here. And so I'm looking for a number that is bigger than 4 and bigger than 6 because we're only talking about the denominators right now. So I'm looking for what number that's bigger than 4. It can be the bigger number, so it could be 6, but we're looking for a number that both 4 and 6 both go into evenly. And so if I took 6 goes into 6 one time, but 4 goes into 6 1 and something, right? It's not a whole time. It doesn't go in evenly, so we can't use 6. 4 goes into 8 evenly, but 6 doesn't go into 8. And so we're looking for that bigger number. And so I find 12. 12 is the number that they both go into evenly. And so I'm going to rewrite this, and I'm going to put 12 over here because I want to change this and let the 6 become a 12. I also want to do the same thing over here, and I want to change this to also become 12. I'm going to have to sneeze, sorry. Okay, so I'm asking myself, 6 goes into 12 how many times? Or 6 times what gave me 12? And so we say 2. What I do to the bottom, I also have to do to the top. So I multiply the bottom by 2 because 6 times 2 is how I got 12. So I'm going to multiply the top by the same thing, and 1 times 2 is 2. So this is now gone, and my new fraction, this guy, is what I have in its place. Okay? I'm going to do the same thing to the other side over here. 4 times what gave me 12? Well, 4 times 3 gave me 12. What I did to the bottom, I'm going to do this to the top. So 3 times 3 gives me 9. And so remember that this is gone, and this is my new fraction. And so I bring it down, and these are the two new fractions that I have. I still have an addition problem because that's what it was to begin with. And now I have common denominators. I'm going to bring my denominators straight over. I'm going to add my numerators, which is this, and I'm going to add 9 plus 2 gives me 11. And so 11/12 is my final answer. Okay. All right, I'm going to show you a little bit different way. We're going to get the same answer, but I want you to see that for this, it was a lot of guessing and trying to figure out what number both 6 and 4 both went into evenly. And so we went through some steps that could be really hard for some students. And so if you're one of those students that struggles with solving that problem by finding this 12, maybe this next example is a little bit easier of a way. I'm going to work the same exact problem. And so I'm going to work 3/4 plus 1/6, which is that same exact problem that we just had. And I want you to see that we are going to multiply our denominators together to find our new common denominator. Because if we multiply them together, obviously they both go into this number that we're going to create evenly. So 4 times 6 gives me 24. And so I have 24 is the new denominator for both of these problems. How did I get it? I took the denominators in the problem and I multiplied them together and I found 24. All right, so now that we're done with that hard part, we are now going to keep with this easier trend, and we're going to multiply from bottom to top, and I get 4. 4 times 1 is 4, right? And so that's where I got this. You start from the bottom to the top. Whichever side you end on is the side that the fraction goes on. Okay, that top number goes. From the bottom to the top, I end on the left, so this answer, 3 times 6, is going to end up staying on that left side, and 6 times 3 is 18. And so now I have a common denominator of 24. And now I'm going to add 18 plus 4. When I add 18 plus 4, it looks like I get 22. So if I simplify this, I can divide both the top and the bottom by 2. And when I finish that, I get 11 twelfths, which is great because that's what I got working it the other way. Okay? So how did I solve this problem? I multiplied the denominators together to get my new denominators down here. I brought down my addition sign. I multiplied from the bottom to the top. The answer stays on that same side. So on the right side, here's my 4. From the bottom to the top, the answer is 18, and the 18 stayed on the left side. I have the common denominator. I brought it straight over. I added my top numbers, and then I simplified. Final answer. This is the way that I would like to teach it. This is the way that I like to use it. For me, it's just easier. Anytime that you use this method, there will be simplifying to be done because you're not finding the smallest number that they both can go into. You're just finding a number that they both can go into. So let's try another one using this method. Let's do 2/3 plus 1/5. Okay. I'm going to multiply the denominators together and I get 15. Remember what the denominators are giving you is the new denominator for both fractions. And then I'm going to multiply from the bottom to the top and get 3. 3 times 1 is 3. Bottom to the top on the other side, and 5 times 2 is 10. Denominators match. I bring the 15 for the denominator straight over, and then I'm going to add the top numbers, and I get 13/15 as my final answer. Okay. All right, let's go ahead and work on one that's a mixed number. Kind of move into some a little bit harder stuff. So the problem is 8 and 5/6 plus 7 and 4/9. All right, I know what you're thinking. We learned how to stack these on top of each other and add them and move right on. We can't do that because these don't have a common denominator. And for us to find a common denominator, we already have to use that backward C, okay? And so we're going to use the backward C to get these into fraction formats. And then we'll see that we really don't have a common denominator, right? Because we're just bringing these down. We're not changing anything yet. We're not finding a common denominator. We're just getting these out of mixed numbers. And so I get 8 times 6 plus 5, and I end up with 53, I believe. Right? Is that right? 48? Yes, 53. On the other one, I end up with 9 times 7, which is 63. And then I'm going to add 4 to it, and I end up with 67, I believe. All right, so now we're looking at a problem that we were looking at on the previous page, right? Something that was fractions where the denominators don't match. And that's where we're at right here below this red line. 2 fractions, they're improper fractions, but they are fraction form, and they have different denominators. And so this is that part where we're going to multiply the denominators together to get our new denominators, and then we're going to multiply in the diagonal second. So 6 times 9 gives me 54 as my new common denominator. Okay, and after that I need to multiply in the diagonals. And so I'm going to have to use my calculator because I'm going to end up with a little bit bigger numbers than I really would like to just work in my head. And so when I do that, I get 6 times 67 gives me 402. And remember, I went from the bottom left, I ended on the right, so 402 goes on the right. On the left, I do 53 times 9, and I worked from the bottom to the left side, and so 477 goes on the top on the left. The denominators are the same, so 54 comes over, and I'm going to add 477 plus 402, and I get 879. I know what you're thinking. These are huge numbers. This is awful, right? But it's really not that bad because you would have had to divide a really big number no matter what. So if you would have found 18 to be your common denominator, you still would have ended up dividing like 293 by 18. So no matter how you worked this, you were going to end up with big numbers anyways. So I want to kind of take some space over here and work this out. So I'm going to take 879 and I'm going to divide it by 54. And I know that 87 divided by 54 goes one time, right? And 87 minus 54, as I bring this down, is what I'm going to do. And I find that to be 33. I'm going to bring down my 9. And I know that 339 divided by 54 gives me 6 whole times. Oops. I had to write that backwards. 6. And so let's see. 6 times 54. Oops. Gives me 324. I'm going to subtract these two. And I find 15 to be my remainder. And so that means my answer is going to be a whole number of 16 and 15 over 54. This is my answer unless I can simplify this a little bit better. And so I'm asking myself, is there a number that both 54 and 15 both can be evenly divided by? And so I am trying to find, it looks like they both can be divided by 3. And so 15 divided by 3 gives me 5, and 54 divided by 3 gives me 18. And so it looks like my final answer is 16, so that whole number, and 5/18 as my final answer. So you're just going to have to simplify and break it down and work through it. If this part right here is the hardest part for you, then you need to make sure that you ask me for help, okay? Or in this small group work time that we have, make sure that you ask one of your friends or somebody in your group, because it's possible that somebody else in your group may have the same struggle and only one of you can explain how to do it, okay? All right, let's do one more of those. And we're going to use this one as a word problem, okay? All right, the word problem is, oops, sorry. John ran so many miles. Bob ran so many miles. All right, so they set it up for us to already see that this is going to be a subtraction or a difference problem, because it says how many more, right? I need to know how many more he ran than somebody else. As I plug these in, this is 12 miles, 12 and 7/8 miles, and 14 and 3/4 miles. All right, so we already know Bob ran more because 14 is bigger than 12, right? That's common sense. So if I keep working this problem, I know that I'm going to subtract the two of them. We always have the bigger number minus the smaller number, and so I'm going to write it out like this: 14 and 3/4 minus 12 and 7/8. Okay, mixed numbers have to use that backwards C format to get them into improper fractions, and so I have 4 times 14 plus 3. On the other one, I have 8 times 12 plus 7. The denominator on this one is going to be a 4, just like it was, and on the other one, it's going to be an 8, just like it was, and I'm going to bring down my subtraction sign. And so for this problem, I'm going to use my little calculator here, and I'm going to have 4 times 14 equals, that'll be 56, plus that 3 right there that I just said, so plus 3 is going to give me 59. The other side is going to be 8 times 12, which is 96, and 96 plus 7 is going to give me 103, okay? So, is that right? I gotta check my work here. Oh yes, because the denominator is different. I was thinking if I subtract that, it's gonna be off, but I'm not looking at the whole picture here. Okay, so let me group all of this together to make me some space on the screen. And the next step is to notice that we do not have a common denominator, and so we're going to have to work on that and find a common denominator between these two bottom fractions here, which is 59/4 minus 103 eighths, basically. All right, so for us to do that, I told you that we will multiply our denominators, and we find 8 times 4 to be 32. We're going to multiply from bottom to top on this side and bottom to top on the other side. And so 4 times 103 is going to give me 412, and I remember I go from bottom to top right, so it's going to stay on the right. When I multiply from bottom to top left, I'm going to stay on the left. So 59 times 8 gives me 472. I keep the denominator. Once they match, I'm going to bring it straight over, so there's my 32. And now I'm going to subtract the 472 minus the 412, and I find this to be 60. All right, so I can divide or I can simplify first, and I see that they're both even, so I'm going to go ahead and divide by 2 as many times as I can to get this to be as simple as I can. So I end up with 30 over, let's see, 16, I believe, 16. They're both even. I'm going to do that again. Double check here. Okay, and so I'm going to end up with 15 over 8. Doesn't look like they can simplify anymore, so I'm going to use division here and see how many times 8 goes into 15, and it looks like just one time. And so when I subtract, I bring this down and I put 8 underneath there and I subtract, I get 7 as a remainder. So this is my whole number of 1, 7 is my numerator, my remainder, and the 8 was already the denominator. And so this is the answer that I found, but what is it? Remember it was a word problem, so that's always something that it means. So I found that Bob ran 1 mile, 1 7/8 mile more than what John ran. And so that's the boxed answer, the 1 7/8. All right, this is the end of your, I believe this is 2.6 lecture video.